Hi, my name is Wes. My amateur radio call sign, W3KW. This is one of many variable AC power supplies that I've built. They're also known as auto transformers or variacs. Variac is a brand name, but it's sort of been hijacked by most people that use these types of variable AC power supplies as a general name for them. But this one was inspired by a build by Terry Dayton, N6TLU, and he has a YouTube channel that I'll link below, D-Labs, and the inspiration came from him. This was built from a repurposed Eico 1060 Battery Eliminator, and the case was in great shape, and there's really no reason for battery eliminators anymore. Simple power supplies will handle most of those tasks, but a variac comes in very useful in the ham radio shack to reduce loads or line voltage when using vintage equipment, or to safely bring up vintage gear or refurbished gear safely, so that you can determine if there's an overload somewhere in the restoration or in the old device you're trying to power. So just real quickly, here's the power switch. Now this is cannot handle 4 amps, this slide switch. So this little fuse you see here is for a relay inside. So this power switch merely engages a relay, which then can easily handle the maximum 4 amps of this unit. I'm pretty sure the variac is like 4.75 amps, but I limited the fuse to 4 amps and put this warning here just to keep it within the limits of the variac. This is a thermal circuit breaker here, which when it blows, it can be reset. You just need to wait about 2 minutes prior. So this switch will allow the meters to show either the variable voltage set with the auto transformer or variac, or the full line voltage, and which will also present here at the output. I added a pilot light, and the Simpson meters were used off of eBay. They're pretty high quality meters, and they don't give them away, but they're not super expensive either. There are inexpensive versions that look just like this, except it doesn't say Simpson inside, available at Zorro.com. I use them frequently. These screws are just for looks, just aesthetics. These small screws here, I believe, are the ones that hold the variac in, if I'm not mistaken. I'm going to open it up and show you the inside in a minute. It's been a while since I built this. And then this is a Hobbs meter. A lot of aircraft have these. And this is a great way to, if you're burning in a restoration, to know how long it's been on, if you wanted to document it. Kind of a gee whiz thing, but I thought it was pretty neat to add that in there. So that's active and turning anytime the power switch is on. So the case is in great shape. Let me spin it around. It's got this nice spring-loaded handle that retracts. The case has been repainted. I have strain relief and the power cord, and then the power cord detaches from the electronics inside using an Anderson power pole connector. So let me open it up and I'll show you the inside. You know what? Before I do that, so I don't have to do it twice, I think I'll power it up and kind of show you it while it's powered up. Hold on one second. Okay, I have it plugged in to an isolation transformer. You can see it sort of in the background over here, and that'll allow you to work safely on devices that particularly don't have their own transformer or a hot chassis. But it's a great way to keep your devices under test, isolated from things like your oscilloscope, so you don't create an unwanted ground loop and fry a circuit or your oscilloscope. And anyway, I have a load plugged in here. These two banana jacks can be used with an external meter if you need a more accurate measurement than these meters provide, but generally these are more than accurate enough. And basically there were 2 holes there that I got to use, so there we go. So I'll turn it on. There's our pilot light. Let's look at the line voltage. So that's full line voltage being presented to the load, and we're at 125 volts, 126 volts. It's pretty high line voltage here in the house, and we're drawing about half an amp. The beauty of having a homemade variac is that you get 2 meters because you'd installed them yourself, so you can monitor amperage and voltage at the same time. With most store-bought units, there's only 1 meter and a switch that goes back and forth between voltage and amps. So it's a pretty convenient way to and safe way to monitor your device under test. So now we're in variable, and I'll bring up the power slowly. You can see there's 60 volts and about a 1/4 amp or so, and 90 volts, just under a half an amp or so, 120 volts, and the max is about 122 the way I have this wired. Most variacs or auto transformers, when you're wiring them, give you a few options, whether you want more voltage or if you want to limit it to lower voltage. I usually choose the lower voltage wiring because 115 is about where I run most of my vintage equipment, because that's what the voltage it was designed to operate on. So let me turn it off. I don't know if you can hear the relay when I do that. Yeah, you can kind of hear it. You might have heard the switch, but there's also the relay in there. Anyway, I'll show it to you in a second once I get it apart. Okay, here's the inside. I'd forgotten. I didn't use Anderson power pole for this cord. That must be one of the other variacs I made. But I used these strain relief. They're pretty standard strain relief. And to make them easy to get in and out, they make a tool that you can use to install them, and it grips the cord once it's in there, and then you use this pliers here that fits it perfectly to install this strain relief in your builds. Anyway, I can't remember where I bought it, but probably Amazon or something like that. DigiKey, one of the suppliers. Anyway, so this is the relay I was telling you about that handles the load switching. So it's a low voltage or load on the switch side, and then the most of the load that the variac and the device under test carries is on the side that can handle it, as opposed to putting all that load on this switch. And then here's the thermal fuse, the selector switch for line or for variable output, the ammeter, the voltmeter, of course the variac, the pilot light, the fuse for the relay, and then the outputs. So these plugs are installed by buying a 1-inch or 7/8 square hole plug or knockout punch, and you can just use a wrench to punch them out. You drill a pilot hole, put the bolt through, and punch a square hole out, and then these pop right in. Every once in a while they're a little wiggly. I use some silicone glue to kind of tighten them up, but it's really rock solid. And so that's the inside on. Here's the Hobbs meter in the back. Anyway, I'm going to button it up and put it back to use in the shack. I have several more of these that I'll put into future videos. If you like what you see, give me a thumbs up. If you want to learn more about ham radio, go to qrz.com or arrl.org. And happy hamming. 73 for now. W3KW.